Hey, welcome to Steve Tech. In this episode of Steve Tech, we're going to cover the SMX hoop. And what this is for head gasket sealing. So I'm going to show you how they work, what they're doing, and how we actually install them, because it all does matter and does make a difference. So first thing I'm going to do is I'm just going to actually just kind of draw out a little picture here for you right on the cylinder head of how the normal O-ringing works in the old school normal deal. Okay, so the first thing you do is, so you would have somebody that would come in with a hand tool or on a boring bar, and they would machine a little square groove in the deck surface. So pretend this is just the deck surface of the block, okay? And then they will take a piece of wire, usually 041, sometimes you can do 051, a piece of wire that would then come in here, and they would put that wire in there just like that. And then of course, since you're beating in a wire all the way around, you would then have a split in between. So it's just a piece of wire that ends up going in like that. Okay, so you would typically do that in a block is the normal way of doing that. You normally would, old school way would be, you'd put that O-ring in the block. So you'd machine that groove in the block, a little square groove. You press it, or you would tap in a piece of wire, okay, and it would sit in just like that. You put in that piece of wire, you'd have it stick up 10, 15 thousandths is a lot, but 10 thousandths or so would probably be the normal deal. And then that would emboss into the head gasket. Then what you would do on the cylinder head, the proper way of doing this, and a lot of people don't do this, they just put that O-ring in there and think that that's going to do all the sealing. It doesn't. What you then need to do is, let's pretend this is the block side. Okay, this would be the head side here, and you need to make a little receiver groove in the head, so that ring material, that a wire material would push up through the gasket and into the receiver groove. So it kind of goes like that, real lightly. But as you can see here, some of the problems with the just using a piece of wire are that it has that split in it. Then it also is that it has all this area here where it's not filling the entire groove properly. Okay, so that's the old school way of doing it. You would machine a groove in the block, you would put wire in it, you would then properly machine a receiver groove into the cylinder head so it all matches up. Now all this stuff has to be lined up right. We just got done fixing a block for another customer of ours where the O-ring was here and the receiver groove was over here in the head. Obviously that doesn't work. Didn't work well at all. So we fixed all that and had to change it. So the way we do the SMX hoop is, first thing you'll notice is this is one piece. This is cut out of a one piece of stainless steel tubing. Okay, it is square on one edge and radiused on the other. This is 050 wide, so 50 thousandths width right here. It's 85 thousandths tall here. And what we do is we machine these into the cylinder head. And we'll take you over to the cylinder head machine here in a minute, and I'll show you exactly how these cut. But what we do with this is we machine these into the cylinder head. So this hoop will then go into the cylinder head. I put them in the cylinder head because if there ever is a problem, I could put them in the block, and it would be a more sometimes it would be a little more permanent fix. But if it ever blows or does have any kind of problem where it does end up blowing through the hoop, it is much easier to fix the cylinder head than it is to fix the block. So we do it backwards from the traditional way. We put this hoop in the cylinder head and we put the receiver groove in the block. And I'll go show you the doing the receiver groove in the block after we do the cylinder head. So the way this now works is we have this one piece, there's no split, there's nothing in there to ever leak. It's taller, and I'll show you why and how this is working now. So now what we do is, this is traditional wire ring. This is a wire ring style. Now we come over here, and this is the way we do it here. So in the cylinder head, we machine a now deeper groove. We machine in this 0.85 thickness right here. We machine this thing in between 65 and 70 thousandths deep. So deep this way. Now, because that hoop is square, the hoop actually goes right straight in, is square, fills up the groove, hits in the bottom, nice solid, and then sticks up with our protrusion of in between 15 and 20. Kind of depends on how I want to set it up. Generally, we'll set that up at about 15 tall. Then in the block, so this is now the head side. Now the block side, we then do a slightly wider groove for the receiver. We make it 60 thousandths wide, so it has a little bit of press that it can go in there, and so that head gasket then fills up all this area here, fills in this area. So when you actually take these gaskets off or take the head off, you'll see the hoop is still in the head, nice flat secure, in there deep, so it has keeps it from moving, keeps it from shifting, keeps it from doing anything. And you'll see that it leaves a little square groove into the block. So this side of the head gasket, when you take it apart, looks square. This side of the head gasket here, you can see how it was round and going up and intersecting into that receiver groove. So this is why this is much more solid, much better, no splits, no leaks, and we can get better protrusion right here into that head gasket versus here where you just kind of have this round wire kind of trying to press up into here. And it's pretty hard to get 15 thousandths protrusion on these. Like I said, normally you're up in the 10 range or so, sometimes less than that. And so what we'll do here, now we'll go over and we'll get the machine running, and I'll show you exactly how we do this on the CNC machine, because it's very hard to do these without that. So you're having to use the dowel pin location here for reference, and we use the dowel pin location on the block so everything all lines up. So we're machining this hoop here in the cylinder head, and when you put the cylinder head on the block, it needs to go into the proper surface, or into the proper location on the block, otherwise it's off. Okay, so we'll get the machine set up, and then we'll show you a video of exactly how the CNC machine circle interpolates and cuts a perfectly round and perfectly flat and true groove for the hoop to go into. Alright, and now you can see we're at the machine excuse me, and we're cutting that groove in order to put the hoop into it. So the CNC, you know, we're obviously going to close the cabinet, turn on the coolant, and continue cutting. So we just wanted to do the initial cut here. So this thing's going to sit there and just continue to circle interpolate and cut this groove into the deck surface, and then it'll move over 4840, 4840, 4840 in order to put everything in a specific location based off of the dowel pin location. So this is how we put those hoops in, and I'll show you this hoop real quick. The one thing that you'll notice is that, you know, like I said before, this is a one-piece stainless steel 085, 050 hoop, and this hoop alone, this whole process is expensive. Okay, I mean, this hoop alone cost me $35, so you got 8 of these, and then plus all the machine work of doing this whole job right, of machining the groove in the cylinder head, and then go over to the block machine, and then machining the receiver groove into the block. So it's quite an entailed process, but currently, as far as I understand and know, this is still the current way they do Top Fuel. Most all the Pro Modifieds, if not all the Pro Modifieds. And obviously this is what we do. So I feel this is the best way of doing this probably in anything in that 2,000 horsepower and above area. I like to do this. Typically, I don't use actually, I backtrack a little bit on that. Typically, I don't use an MLS head gasket for much over 1,500 horsepower. I know there's lots of people that do a lot more with it, but I prefer to go the better route that I know is the best that we could do. So why not do the best we could do, even if it doesn't technically need to have it done. Okay, and now I'll show you the block and how we have to put the receiver groove in. So remember, we have the hoop. So basically the block is like this. We're machining this receiver groove, and the hoop is pushing through there, through the gasket, down into the receiver groove, versus just flat on flat like any other kind of gasket, multi-layer steel gasket. Anything that's got a flat deck surface, a flat head surface, that's all you're at. But here, we're machining that receiver groove. That's what we'll take a look at here with the hoop that goes in just like that. Okay? So as you can see here, it's running in the machine. We've already cut these hoops, or I'm sorry, the receiver groove, right in the block. Now this sleeve, like we talked about sleeves in the other video, is still protruding. So this sleeve is protruding 3/1000ths on this block. And the receiver groove on this is 15/1000ths deep, is what we're cutting at. And we're cutting that receiver groove at 60/1000ths wide. So just slightly wider than what the hoop is itself, the hoop being 50, and this is 60, so that gives that little bit of area around there. So it touches those chambers, or those side walls right there, and really gets a best possible capture and sealing of where the exhaust gases would have to go around, versus two flat surfaces and the compression or combustion pressure just trying to escape through there. Here, it's trying to escape through that, which is a totally different deal. So as you can see, we're cutting it on the CNC machine, so everyone is exactly right. 4840 bore spacing on this big block Chevrolet. So 4840, 4840, 4840, 4840. That way it gives us, like we talked about, the in between, your dimension in between the cylinder bores right there. Because I don't like to, I'd like to have that material in between. Like to see that, and don't want to have the rings butted right up like that. Like to have them a little bit of space and material in between, so it has more clamping area on gasket. So anyways, that's how we do the block. The machine automatically flips this thing over, does the other side. You can do this with a hand tool. Obviously, I don't think it's nearly as good as what this is. I mean, this is one of the reasons why I have this machine, is so we can actually put it in, program this to cut perfect circles, perfect depths, so all our stack up is exactly the same. So anyways, that is how we do the SMX hoop and receiver groove. So here's the block, and showed you the heads already. So anyways, I'm Steve Morris, Steve Tech. Have a great day.